Now let's review motion by doing some exercises. First off, let's calculate distance and displacement. Our T-Rex is sauntering along a path. He moves from position 0 to position 10. Then he turns around and goes back to position 6. Can you calculate the distance he travels? How about his displacement? Why don't you pause the video and do your calculations? Alright, if you're ready, let's work through his distance together. We'll have to separate his journey into two parts. First, he moves from 0 to 10. His final position, 10, minus his initial position, 0, is 10. Then he turns around. Then his final position is 6, and his initial position is 10. So we end up with -4, but this is distance, so we don't care about the direction or the sign in this case. We can add these two values together to get 14. Let's say our units are in meters, so that would be 14 meters. How about his displacement? Here we only have to worry about his initial position and his final position. So his final position, 6, minus his initial position, 0, is 6. And we know that he travels to the right. So we get 6 meters to the right. Let's do some work with velocity and acceleration. You and your friend are in a nice car cruising along at 10 meters per second. Then you realize you're being pursued by an angry T-Rex. Oh boy. So then you accelerate for 10 seconds, ending up at 310 meters per second. That's awfully fast. Can you calculate your acceleration during these 10 seconds? Why don't you think about it for a minute? Now let's work through it together. Your final velocity, 310 meters per second, minus your initial velocity, 10, divided by the time, 10 seconds, is 300 over 10, which is 30 meters per second squared. Oh, I'm sorry. Yep, that's right, 30 meters per second squared. Alright. Let's do some more calculations with velocity and acceleration. Let's say our T-Rex is going for a nice stroll at 2 meters per second. Then he gets scared by a mouse. So he accelerates at 5 meters per second squared for 10 seconds. Can you calculate his final velocity? Why don't we give this a shot? Let's see. Velocity over time is acceleration, so his change in velocity must be equal to his acceleration times the change in time. So the change in velocity is equal to 5 meters per second times 10 seconds, which is 50 meters per second. But remember, this is only the change. We can't neglect his initial velocity, which is 2 meters per second, so we'll add the two together. 2 meters per second plus 50 meters per second is 52 meters per second. That's awfully fast. Next, we run into a rather boastful T-Rex. He says that he ran 100 meters in 5 seconds. Let's calculate his velocity. Like any sensible runner, he's concerned about how quickly he was moving. Why don't you think about it for a minute? Alrighty then. His velocity is equal to his change in position over the change in time. We know that he traveled 100 meters in 5 seconds, so his velocity must be 20 meters per second. Let's do one more. Let's say you make a wrong turn, and then you're driving at 20 meters per second for 30 seconds. You'd like to know what displacement you made in the wrong direction so you can find your way back. Let's give this calculation a try. Velocity is equal to the change in position over the change in time. So the change in position must be equal to the velocity times the change in time. This is 30 seconds times 20 meters per second. So we get 60 meters. Very nice. This wraps up our unit on motion. Congratulations!